Hello, guys. This is question 29 on stoichiometry. We want to calculate the volume of steam produced at s.t.p when 18 grams of propyne is combusted. Okay, so first off, what's propyne? Propyne is C3H4. It's under the alkyne family, and the alkyne family have the general formula of that, CnH2n minus 2. So if prop means that we have 3 carbons here, it means that C3H2 times 3 minus 2. So that's C3H2 times 3 is 6 minus 2 is 4. So that is the formula for propyne. Okay? So if that is our propyne and we're doing combustion, it means that C3H4 should be reacted with some oxygen. What do we get? We get CO2 and we get H2O. Do you remember this one? We've said it before, right? CO2 and H2O. Okay, so let's balance it. Balance carbon first. 3, so 3. Next is hydrogen, 4. So we'll put the 2 there, so that gives us 4. Now it's time to balance the oxygen. Let's check. What do we have here? 3 times 2 is 6. 2 times 2, 4. That's a total of 10. So we need 5 here to do that. Are you sure? Are you sure what you're doing? 8, 6, 2. Oh, I see. 2 times 1 is 2, right? Not 4. 2, guys. So 3 times 2 is 6, and this is 6. Right? So that means the total of this is 8 here. Okay? And that would mean this is not 5, it's not 5. It should be 4. Yes, 4. Okay, so that's it. Hope you're able to spot that. Okay, so if we have this here, it just means that this is our balanced equation and we can work with this. Now, to calculate the volume of steam, that's the H2O steam, at s.t.p when 18 grams of propyne is combusted. Okay, what is the molar mass of propyne first? Molar mass is 3 times 12 plus 4 times 1. Okay, now these values here, you use the one you're given in class, okay? What is the molar mass? 40. Now, what is the moles of C3H4? Do you remember how to get moles? It's mass divided by molar mass. So, the mass of propyne is 18, and you divide that by 40, so you get 0.45 as the moles. From this equation here, we can see that 1 mole of propyne would produce 2 moles of steam. Okay, it's water gas, so that's steam. It means that if 1 mole of C3H4 produces 2 moles of steam, H2O, 0.45 of the C3H4 would then produce X moles of steam. Simple proportion there, and X becomes 0.45 multiplied by 2, which should give us 0.90 mole of steam. Calculate the volume of steam at s.t.p. Oh, what happens at s.t.p? Yeah, remember, 1 mole of anything, any gas at s.t.p. It's not easy to like write and talk. 1 mole of a gas that's steam at s.t.p. is actually 22.4 liters. So it means that 0.90 mole of the same gas at s.t.p. would be 0.90 times 2.4, and that would give us 20.16 liters, or you can say 20 liters. Yeah, we'll do that. And that is our answer to the question. Okay. So let me know if this was helpful. Is there any part you didn't get within this process of solving? If there's any part you didn't get, just let me know. We'll see whether we can explain it to you in the comments as well. Or you can send a DM if it's like really, really so hard. But I believe if you should go over these questions again, we're going to 100. This is 29. If you should like practice more of this, you'll be better at stoichiometry. And that's the aim. Okay, so I shall see you on question number 30. Take care. And by the way, you can like this video and subscribe. If you're watching this on YouTube, subscribe. And you can also follow us on all our social media handles. You can check out copychemistry.com if you would like to make a special request, or if you need to book a tutor, or if you want to learn how to use a calculator better, or if you want to learn tips about student life generally, you can find it there. So just become a better person, because that's like the aim at the end of the day. Okay, so I shall see you on question 30. Okay, bye bye.